So this lathe has a D1, it's called a D1.6 spindle. Pretty big spindle for a small shop lathe. Alright, so now we're going to go ahead and get a collet. So this is 3/4 steel, so I need a 3/4 inch collet. Oh, so I'm going to go ahead and put an automatic stop on this. So every time I take these in and out, it'll be at the same spot every time, so we can get my stop. These are called collet stops. So what these do is they screw in the back of a 5C collet. They're adjustable and you can push the stop in and out, so this is sitting at the exact same spot every time you take it in and out. So it looks like it's still set up from the last time I did this. So that's perfect.
Nice.
Just right there.
Nice.
So now that I have this stop in there, every time I put these in and out, it's going to be at the exact same spot, so I can use my DRO. I'll go over that here in just a second. Alright, so what I'm going to do on these next couple operations is I'm going to go ahead and first thing I'll do is I'll face it so it's flat. Then I'm going to drill a hole a certain depth. And then I'm going to use a reamer and I'm going to ream that hole to a certain diameter. And then I'm going to go ahead and thread it.
Nice,
I'm
okay.
going to do all three of those things in this next setup. Now when I do my 30 at one time, I will probably drill them all, ream them all, and then thread them all on the same setup. But we'll just do one at a time. Alright, so what I'm going to do is I'm going to go ahead and face this off, make it flat. I'm going to go ahead and pilot drill the starter hole. I'm going to drill a 1/4 inch hole all the way through the muzzle brake. And I'm going to drill the rough minor diameter of the threaded hole with this. I think this is a 64th smaller than it needs to be. And then I'll go ahead and use my reamer. This is a 15/32 reamer. And I'll go ahead and finish the minor diameter with this reamer. So I'll do that first. So this is all set up to fit right in between the specs on the 1/2x32 thread. And I think the spec, if I remember right. So for class 3, the minimum diameter is 471 to 466. That's going to be the spec for class 3 thread. And this 15/32, I believe, falls right at 468. Let me make sure. So 15/32 at 468. So that's right in the middle of the range. And that's what we're going to do now. So the first thing I'll do is I'll go and turn my inverter on. I got a 3-phase converter. Everything in here runs on 3-phase. So I've got my tool here. Looks like I need to adjust my tool wrench. First thing I'll do is I'll go ahead and face this off, and I'm going to start using my DRO. The DRO is going to let me put this cutting bit in the exact same spot every time I move it.
Okay.
And since I have my collet stop in there, these are always going to be in the exact same spot. So when I set this x-axis to, the z-axis to 0, I know they'll all be the exact same length when I'm done.
Okay.
So I know this is a 16th of an inch long, so I'm going to take a 32nd off of this side. So a 32nd of an 32 thousandths is a 32nd of an inch. So I know that I'm going to go 32 thousandths from here. So this is, I'm going to set to 0, and what that does is it's going to tell me exactly where I'm at on the z-axis. Next to that, just to 0. That's exactly where I was last time before I moved it.
Okay.
But I need to take out 32 thousandths, so I'm gonna go ahead and do that first. I'm gonna turn this pretty fast. I'm gonna turn it at 900 RPM. I can turn it faster, I just don't want to because it gets kind of noisy. I'm just gonna do a pretty simple facing cut.
That's the new 0?
That's my new 0, so all of these are going to be cut the exact same. Alright, so what I'm going to do now is I'm going to go ahead and do these 4.
You just faced it, right?
I just face it, so now this is perfectly square. I'm going to go ahead and take it out. I'm going to do the other 3 real quick. So what I did was I went ahead and pushed this up against the stop. So I know it's sitting at the exact same spot as the other one. So I'm going to go ahead and put this on 0, which is already at 0, and I'm going to do another facing cut.
All right. Pliers rent these per pliers.
How long have you guys been here? We got here at 9:50.
Alright, so all 4 of these are exactly the same length from the stop now.
Okay.
That's what I was doing there. So I'm going to go ahead and take this stainless one back out. I'm going to start with the 1055 version, just because they're a little easier. Stainless is pretty hard. Stainless takes a little more work to make perfect. And in the essence of saving time, we're going to switch. So I'm going to put the side that I machined out and make it touch the stop, so it's sitting at the exact same spot as it was last time I was in there. Plus or minus maybe a couple times. Alright, so the next operation is going to be drilling the pilot hole, starting the starter hole. I'm going to use the starter drill to do that.
In the wrong spot. And do what again?
I'm going to make a starter hole.
Starter hole. Okay.
So I can drill a 1/4 inch hole all the way through it. So this is a special drill bit. This is really stiff. It's a stiff drill bit to make a starter hole right in the middle. It doesn't have any flex to it. That's why typically when you're going to drill a big hole, a deep hole, you need to use a starter bit.
Okay.
So I'm going to drill just a little bit, just enough to get it started. And I'll do that at the same RPM. I won't change anything. We're done with this carriage, so I'm going to go ahead and turn all the feeding off. going to go ahead and switch to my 1/4 inch drill bit. And this is going to be the basic diameter for the smallest caliber that I typically do. This would work for a 250. That would work for a 223. That's about what you would use for a 223.
Okay.
So that's why I make everything 1/4 inch, because that's typically the smallest thing people do.
That's the standard, huh? For
Well,
most people?
That's the smallest caliber that I've done muzzle brakes for.
Oh, okay, okay.
So I'm going to go ahead and drill this all the way through. There's no need to use a DRO on this because I'm going to drill the hole all the way through. So. It's all the way through, I can tell. Now the hole all the way through. The hole's just all the way through.
What's your revolutions per minute on the thing?
I'm leaving it at 900. I'm going to turn it down here for the next drill.
Well, that was pretty cool.
That's just a drill. Alright, so I'm going to go ahead and drill. This is the going to be the rough minor diameter. So I have a little drawing here. So I'm going to make it 550 thousandths deep. That's going to be the finished. That's going to be the finished depth of the thread shank.
What was the number?
550 thousandths, so just over half an inch. So what I'm going to have to do is I need to make this. I'm going to go off the graduations on my tailstock to use that, go to that depth. I'm going to turn this down quite a bit.
900 to, what are you thinking?
I'm going to turn it at 385. 385 revolution per minute. So I'm going to go ahead and use my dial here. My graduation is on my tailstock, so there's right at, I'm going to use that as my 0. I'm going to advance this until it touches. Alright, so I'm going to go 550 thousandths, so that's going to be just over half an inch. So this is graduated in 16ths. So 550 thousandths would be one graduation past the half inch mark. That would be 570 thousandths, 60 thousandths, just shy of that. I'll do the finished depth with the reamer.
Okay.
That's what I'm going to do. So I'll go ahead and pour this.
Oh.
Use a little coolant. actually, I'm going to use the dial. I'm going to use the graduations on the tailstock. Not those, but these.
Not these ones. These ones, huh?
Yep. So this is 1,000 per graduation. So I'm going to go 550 thousandths is what I'm going to do. So one revolution is 100,000. So I'm going to do 5 turns, and then I'll do 50 graduations after that. So. There's 100 thousandths, 200 thousandths, 300 thousandths, 400 thousandths. So there's 500 thousandths, that's exactly a half inch. And I'm going to go to 550. So there's 550 right there. So now I know that hole is exactly 550 thousandths.
Exactly at 550 thousandths.
Done with this drill bit.
Barely looked like it was even moving.
I use nice sharp drill bits. I don't skimp on drill bits.
Danny is not a skimper on the drill bits.
So now I'm going to use my 5/32 reamer, and that's going to make that hole exactly 500 and what was it, 462 thousandths, I think it was, 466 thousandths. Right in the middle of the range where it needs to be. It's the same thing here. I'm going to use my graduations on the hand wheel. I'm going to set it at 0. I'm going to advance until I touch. It's touching right there. So I'm going to advance this 550 thousandths.
550
I am
thousandths.
going to, I'll leave the RPM the same. Make sure I
Yeah,
got
350, right?
385 RPM.
Oh, 385, okay.
So there's 100 thousandths, 200, 300, 400, 500, and I just bottomed out. Let's go out and see what that did. So let's look here. Let's take this out. Check it. Thinking probably what happened was, yeah, this has a taper on it. So what happened was when I touched off, I was already about a 30-second in there. That's why I couldn't get the full 550. I'm gonna get my caliper out and measure that and just make sure it's a full 550 thousandths deep. Let me grab my caliper. So typically when I'm doing this for reals, I would have drilled the hole, took this out, put another one in, drilled the hole, took the other one out. I would have done it more of a production style. That way when you set this up,
You don't have to keep changing.
you don't have to keep
anything.
changing stuff. And once you get it set perfect, you leave everything just like that. And then you can do all 20 of them pretty quick.
Right, right.
We're just gonna do one at a time here. So I need to make sure this is 550 thousandths. That's what I'm doing.
Looking for 550 thousandths is the magic number.
There's the shoulders. Let's see where we're at here. So what I'm going to do now is I'm going to go ahead and I adjusted the reamer, so now we've got the right depth hole. It's measured at 551. So I'm going to go ahead and do a counter bore at the start of the threads. When you do internal threads, you have to keep in mind that the shoulder on the thread shank, in this case on the barrel, that shoulder is going to have a radius on it. So you've got to take into account. You got to make room for that radius to go into the muzzle brake. If you don't, the threads won't square up on the shoulder. So anytime you're doing internal threading, you got to take into account that radius on the shank of the thread.
Okay.
So I'm gonna go ahead and do a counter bore here. I'm gonna make it just over ½ an inch because it's gonna be a half by 32 thread. So the max OD is gonna be ½ inch. So I'm gonna make it probably 505, just over
505.
½ an inch.
All right.
So we do that. I'm gonna touch off and get my 0. There's my 0. And I know that the thread depth is going to be right around 32 thousandths, so I'm going to go ahead and come out 40 thousandths. give myself plenty of clearance. So I'm going to go ahead and go out 40 thousandths for my 0. I'm going to go in probably. Plenty of clearance right there. That's right at 55,000 still. So that'll take care of the counterboring.
All right.
So that's what this boring tool is for. I know the bottom is squared off because of the reamer. I don't need to worry about that. So I'm going to go ahead and switch to my threading tool.
That's the threading tool right there?
Yep, so the first thing I'm going to do is I'm going to go ahead and find my bottom. Okay, so there's the bottom of the bore right there. So I don't want to go any further than that. If I do, I'm going to crash. I'm going to set that in my Z0. Actually, I'm going to come off the bottom 15 thousandths. Give myself a little wiggle room just in case. So now I'm set 12 thousandths off the bottom. So as I make my passes when I'm threading, I'm going to stop at this 0.
Okay.
Every time, that's when I'm going to disengage my half nuts. So to do internal threading, let me think here. I've got to do some changing.
You gotta do some changing?
Yep, I need to reset my compound. So that's going to take a few minutes.
All right.
All right, so we've got the counterboard done. What I'm going to do now is I'm set up for internal threading. I've got my compound turned around at 29.5 degrees. So what I'm going to do is I'm going to touch off my bit to the ID diameter. I'm going to do that first. So I'm going to turn the lathe on so I can hear it. All I'm going to do is touch off. Right there, I can hear it. So that's going to be 0.
That's going to be 0?
Yep. So I'm going to go ahead and get out. Now I'm going to go ahead and advance my compound 32 thousandths because I know my thread depth is 32 thousandths. And now I'm going to bottom the tool out so I know how far I can go in.
Without crashing, right?
Without crashing. Okay, so there's the bottom.
And you said that's going to be the 0?
That's going to be, that's the absolute bottom. I'm going to come off of that about 10 thousandths to give me a little bit of wiggle room. So we'll make this my new 0, so I'm not going to go any deeper than that right there.
All right.
So let me back out. Okay, so let me put this back to my 0 on my compound. Okay, so now I'm at 0, 0. Right there. So now I know that if I run this in, it'll barely be touching the ID. So to start internal threading, I'm going to advance, I'll probably advance 5 thousandths at a time. I'm going to slow everything down. I'm going to do this really slow. So I'll set my machine up at 32 threads per inch.
32 threads per inch?
So that's going to be LBR1V. Okay, so set up 32 threads per inch. I'm going to slow this way down. I'm going to cut it probably 70 thousandths. I'm sorry, 70 RPM. That's pretty slow. But I want to give myself plenty of time to stop.
Yeah.
Alright, so I think we're ready to start. So I'm going to go ahead and use my thread dial here. 32 threads per inch. I can use any number, any mark. So what I'll do is I'll start the machine. I'll advance to half nuts. And when this gets to 0, I'm going to disengage.
All right.
That's what you do. So I'm going to go
When it hits 0?
when it hits 0.
Okay.
Yep.
Cool.
So I'm going to go ahead and turn this up. I'm going to go ahead and make a 5/1000 cut. And let's see what it looks like here. It's just be a practice to see how fast it's going. So now they're engaged. Yeah, it's going really slow, which is perfect.
All right.
So I'm at 0. I'm going to make sure I'm always at 0 on the cross line.
Always double check the zeros.
Yep. So I'll wait till it gets to a hash mark. Engage it when it gets to that mark using this screw head right there. So now it's engaged. I'm here cutting. When that gets to 0, I'm going to disengage. Check my threads and make sure it's set at 32 threads per inch. I don't want a thread that's an off shit. It's set at 31 threads per inch. I want to make sure it's set at the right thread pitch. So this is the thread gauge. Get my 32 thread pitch gauge out. There's 32 threads right there. So it looks to me like all the threads line up perfect, so it's set at 32 threads per inch.
Nice. That is what we
So now
want.
I'll go ahead and continue on gutting, and I know that I need to go about 32 thousandths deep. So what I'm going to do is I'm going to go probably 25 thousandths, and I'm going to get my gauges out, and I'm going to start seeing if it fits. And I'm going to thread it until it fits. And I'm going to use some cutting oil. Make sure my 0 is at the right mark on the cross slide. Turn this on. I'm going to go to advance another 5/1000ths of an inch. And I'll engage at the next mark. Right about there. And I'm going to disengage, and that gets to 0. Another 5/1000ths. Some more oil in there. Another 5/1000ths. So this is a total of 20 thousandths. I'm getting close. 32 thread per inch is pretty fine thread. So if I was doing this for reals, a production run, I know exactly where I would need to stop, and I would set all of my DRO values, and I wouldn't have to sit here and check each one. I would just do them all at the same time. But since we're only doing one, this one's going to take a little longer. The first one always takes longer, because you got to get everything set. So let's turn this off. See how it looks. Alright, so I know the threads are going to be too small. I know my gauge isn't going to fit, but I want to double check. So this gauge, the go side is going to be just off the minimum. The no-go side is going to be over the max. So this side should go in. This side should not go in.
Which side should go in?
The no-go side. So if the no-go side goes in, it's too big and I can't use it. So that's why I'm going to go kind of slow here. So I'm going to see if this fits. I don't think it will. Yeah, it gets tight. It's close. Yeah, it's tight. So I need to keep on going. And I know I need to go to around 32 thousandths. So we'll go ahead and advance it another couple thousandths. Now we're at a total of 26. So I think we're just going to do one more final pass and we're going to call that one good. We're going to take a real light 1/1000th cut. Alright, threads look nice and sharp. Let's double check. There it goes. Okay, that's bottomed out. It's pretty smooth all the way down. So
That's what you're looking for.
that's what I'm doing. So let's make sure that the no-go side doesn't go in. Or it needs to be tight if it does. Yeah, right there it starts to get tight. Yeah. Okay.
Nice.
So now I know I'm good on the thread. So that is it for this. So this part of it is done. The threading, the boring, and the facing off of this side is done. So I'm going to go ahead and take it out and I'll set it for the next operation.